Hello viewers, in today's session we are going to discuss another important problem from maxima and minima. So here we have to find out the maximum and minimum value of this function, that is y is equal to 3x raised to 4 plus 8x cube minus 18x square plus 60 raised to 5, right? So here we have a polynomial, and this polynomial is raised to some power, that is 5, and we'll see how we can find out the maximum and minimum value of this function with the help of a second derivative test, right? So let us start. So here let us first assume this polynomial as a function, say z. So we'll take z is equal to 3x raised to 4 plus 8x cube minus 18x square plus 60. Then this function y, it takes the form z raised to 5, right? So here we are going to use the concept that if we have a function, say a y, which is expressed in some power of a function f of x, let us say the power is m, right? And we have to find the maximum and minimum value of this function y. Then what we do, we take this function as z is equal to f of x, so that we have y is equal to z raised to m, where m is a constant and this m is greater than 0, right? So to get the maximum and minimum value of this function y, what we do, we take z is equal to this function, and then we'll find out the maximum and minimum value of this function z, right? And once we get the maximum and minimum value of this function z, we can easily find out the maximum and minimum value of this function y, which is z raised to this power m. So we can say that this function y is maximum or minimum according as this function f of x, which is z, is maximum or minimum. And here I will make use of the second derivative test. So let us first differentiate z with respect to x. So dz over dx is given by 3. The derivative of x raised to 4 is 4x cube. Then here we have 8. Derivative of x cube is 3x square. And here we have minus 18 x square. The derivative is 2x, and here the derivative of 60 is 0. So we have 12x cube plus 24x square minus 36x, right? So this is our first derivative of z with respect to x. So let us find the second derivative here. So the second derivative is given by here we have 12. The derivative of x cube is 3x square. Then we have 24 times 2x minus 36 times 1. The derivative of x is 1. Derivative of x square is 2x. So we have 36 x square plus 48x minus 36, right? Okay, now let us come to the first derivative of z with respect to x. Now see, this function z is a maximum or minimum if we have dz over dx is equal to 0. So for z to be maximum or minimum, the first derivative should vanish. So here we have 12x cube plus 24x square minus 36x is equal to 0. So simplifying it, taking 12x common, we have x square plus 2x minus 3 is equal to 0. So we can now have x. Now this 12, when we divide both sides by 12, we can get rid of this 12, and here by splitting the middle term we have x square plus 3x minus x, and here we have minus 3, that is equal to 0. So we have x plus 3, and here we have minus 1 x plus 3, this is equal to 0. So we have x plus 3, and here we have x minus 1 is equal to 0. So the turning points are given by x is equal to 0, x plus 3 is equal to 0, and x minus 1 is equal to 0. So we have x is equal to 0, then from here we have x is equal to minus 3, and from here we have x is equal to 1. So we have here three turning points, right? So let us now test these points for maxima and minima by using the second derivative test. So now let us first take x is equal to 0, and let us find out the value of the second derivative at x is equal to 0. So here we have 36 times 0 square, then we have 48 times 0 minus 36. So this term is 0, this is 0, so we have minus 36. Now this is negative, that is less than 0. Now the second derivative test says that if the second derivative is negative, that is less than 0, then z is maximum, right? And if the second derivative is greater than 0, that is positive, then z is minimum, right? So here the second derivative at x is equal to 0 is negative, that is less than 0. So we can conclude that this point, that is x is equal to 0, is a point of maxima, right? Okay, now let us take x is equal to minus 3. So the value of the second derivative at this point, that is minus 3, is given by taking x is equal to minus 3 here. So we have 36 minus 3 square, then we have 48 times minus 3 minus 36. So here if we multiply both these numbers, we'll get 324, and here we have minus 144, this is minus 36, and 324 and minus 144 is 180, and here we have 36, so this is 144. So this is plus 144, that is greater than 0, right? So this point, that is x is equal to 3, is a point of minima, because here the second derivative is greater than 0. Now let us take x is equal to 1, right? So the second derivative at this point is given by this expression. So taking x is equal to 1, we have 36 times 1 square, then we have 48 times 1 minus 36. So we have 36 plus 48 minus 36. So 36 and 36 get cancelled, we have 48. So this is plus 48, that is greater than 0. So again by second derivative test, the second derivative at x is equal to 1 is positive. So at this point x is equal to 1 is a point of minima, right? So here we have 3 points, 0, minus 3 and 1, and from second derivative test we have seen that x is equal to 0 is a point of maxima, because the second derivative is less than 0, and here the points x is equal to minus 3 and 1 are points of minima, because the second derivative at these points is positive, that is greater than 0. So now this function z is maximum at this point x is equal to 0. So therefore this function y is also maximum at this point x is equal to 0 by this rule, right? Okay, so now here we can find out the maximum value of y by taking x is equal to 0 in this expression. So y is equal to 3 times 0 raised to 4, then we have 8 times 0 raised to 3, then we have minus 8, 18 times 0 square plus 60 raised to 5, right? So here we have y is equal to 60 raised to 5, right? So this is the maximum value of y which occurs at x is equal to 0. So now this function z is minimum at x is equal to 1, right? So y is also minimum at x is equal to 1. So let us find out the minimum value of y by taking x is equal to 1 in this expression. So we have 3 times 1 raised to 4, then we have 8 times 1 cube minus 18 1 square, and here we have 16 raised to 5. So here we have 3, this is 8, this is minus 18 plus 60 raised to 5. So this is 11, 11 minus 18 is minus 7 plus 60 raised to 5. So we have 60 minus 7, that is 53. So 53 raised to 5 is the minimum value of y at this point x is equal to 1. Now z is also minimum at x is equal to minus 3, right? So y is also minimum at this point that is x is equal to minus 3. So the minimum value can be obtained by taking x is equal to minus 3 in this expression. So now we have y is equal to 3 times minus 3 raised to 4, then we have 18 times minus 3 raised to 3 minus 18 minus 3 square plus 60, and here the power is 5. So now y is equal to 3 times minus 3 raised to 4 is 81. Then we have 8 times minus 27. Then we have minus 18 times 9. Then we have 60 raised to 5. And here we have 3 times 1, 3, 3, 8, 24. And here we have minus 216, and here we have 162, and then we have 60 raised to 5. So now we can have 243 plus 60 is 3, 0 and 3, right? And here minus 216 minus 162 is 8, 7 and 3, and this is 5, right? So 303 minus 378 is minus 75 raised to 5. So this is minus 75 raised to 5, right? Because here minus 1 raised to 5 is minus 1. So the minimum value of y is given by minus 75 raised to 5, right? So whereas here we have seen that this function y is maximum at x is equal to 0, and this is the maximum value, that is 60 raised to 5, and the minimum value it occurs at 2 points, that is x is equal to 1 and x is equal to minus 3, and the minimum values are 53 raised to 5, and this is minimum, and here this is also minimum, right? So this is how, by making use of this concept, that is, if y is a function which is some power of other functions, say f of x, then y is maximum or minimum according as f of x is maximum or minimum. So this is an important application of the second derivative test. Hello viewers, in today's session we are going to discuss another important problem from Maxima and Minima. So here we'll solve this problem in which we have to find alpha, where alpha is it belongs to the set of real numbers. If the maximum value of this function y is equal to 1 over 4x square plus 2x plus 1 is alpha plus 1 over alpha minus 1, right? So here we are given a function y of x, and here the maximum value of this function is given as alpha plus 1 over alpha minus 1, where alpha is to be calculated, right? So here to solve this problem we'll make use of the second derivative test to get maxima and minima. So here let us assume this quadratic function as z, right? So z is a function of x, so we can take z is equal to 4x square plus 2x plus 1, so that our function y, it becomes 1 over z, right? Now we'll find out the values of x for which this function z is maximum or minimum, and with the help of those values we can decide that the function y is maximum or minimum for what values of x, right? So here if this function z is maximum, then our function y should be a minimum, right? So this is the concept we are going to use here. When this function z is maximum, then y is minimum, and similarly if z is minimum, then y is maximum, right? So let us find out the values of x for which this function z is maximum or minimum. So let us differentiate z with respect to x. So dz over dx is 4 times the derivative of x square, that is 2x, and here we have 2, the derivative of x is 1, the derivative of 1 is 0, so we have 8x plus 2, right? So the first derivative of z with respect to x is 8x plus 2. Let us find out the second derivative. So the second derivative of z with respect to x is 8 times 1, because the derivative of x is 1 and the derivative of 2 is 0, being a constant. So here the second derivative is equal to 8, that is positive 8, and the second derivative is always going to be greater than 0 for all values of x, right? Now for z to be maximum or minimum, what we do, we put the first derivative equal to 0 and we solve this equation for x. So we have 8x plus 2 is equal to 0, so 8x is equal to minus 2. Taking 2 to the right hand side, we have x is minus 2 over 8, that is x is minus 1 over 4. So here our critical point or the turning point is x is equal to minus 4, and we have to decide the value of z to be maximum or minimum at this value of x using the second derivative test. So the second derivative test says that derivative test states that if the second derivative is less than 0, that is negative, then z is a maximum, and if the second derivative is positive, that is greater than 0, then z is a minimum, right? So let us take x is equal to -4 in this expression, that is the second derivative is equal to 8, right? Now see, the second derivative is independent of x because this is a constant here, right? So the value of the second derivative at this point, that is x is equal to -4, it remains 8, and 8 is positive, that is greater than 0. So this point is a point of minima, right? So this is a point of minima due to the second derivative test, because the second derivative is greater than 0 if when z is minimum. So this function z, which is a quadratic function, z is minimum at x is equal to -1/4. So let us find out the minimum value of z here. So z minimum is given by 4, and here we have -1/4 square plus 2 times -1/4 plus 1. So taking x is equal to -1/4. So we have 4, here we have 1/16, and here we have -2/4 plus 1. This is 4 times 4. So we have 1/4 -2/4 plus 1. So this is 1 minus 2 over 4 plus 1, that is -1/4 plus 1, that is -1 plus 4 over 4, that is 3/4. So the minimum value of z at x is equal to -1/4 is 3/4. So now z is a minimum, and we have y is equal to 1/z. So when z is minimum, then y is maximum, right? So the value of the maximum value of y is equal to 1/z minimum, and this minimum occurs at -1/4, that is 1 over z minimum is 3/4. So we have 4/3, right? So y is maximum at this point, that is x is equal to -4, and the maximum value of y is equal to 4/3, right? And here we are given that the maximum value of this function is alpha plus 1 over alpha minus 1. So we are given y maximum is equal to alpha plus 1 over alpha minus 1. So let us equate these two quantities, because y maximum is 4/3, y maximum is given to be alpha plus 1 over alpha minus 1. So equating these two quantities, we can now frame a linear equation in alpha. So now to get the value of alpha, cross multiplying, here we have 3 times alpha plus 1. Here we have 4 times alpha minus 1. So we have 3 alpha plus 3, that is equal to 4 alpha minus 4, that is 3 alpha. Taking 4 alpha to this side and 3 to this side, we have -3. So we have minus alpha equal to -7, and minus get cancelled, so we have alpha is equal to 7, right? So the required value of alpha is equal to 7. So here the maximum value of this function y is given as this, alpha plus 1 over alpha minus 1. We have obtained y maximum as 4/3. So equating these two, we solve this equation and we get alpha is equal to 7. right? So yes, this is how we can solve this problem. And here always remember, whenever we have a function, say y is equal to 1 over z, where z is some function of x, then z is if z is maximum, then y is minimum, and when z is minimum, then y is maximum. So here we have the second case, because this set is minimum at x is equal to minus 1 by 4.